Okay. So your test will be over 1.3 through 1.5. It will contain some stuff that you have seen before. The first thing that we're going to do is we are going to be finding domains and, yes, Sean said restrictions, yes, but we're going to look at them a little bit differently. And ranges. Given a graph. So instead of me giving you a function, okay, and that was when you looked at domains like restrictions, all right, I'm going to give you a graph, and you're going to tell me what the domain and the range is. Is everybody okay? All right, so here we go. Example 1A. I'm going to draw a graph. And then I'm going to ask for his domain and his range.
I can't tell, is that point on 2 when it's all the way up there?
Does that help?
Yes,
Do you want me to let you do it, or you want me to do the first one with you?
I think I got this one.
You think y'all got that one? Okay. We're going to do set, proper set, and interval, okay, just to stay up on that. All right, everybody okay? Okay, so this is the way I do it. When I'm talking about domain, I'm going to like box my graph in with respect to the x-axis, because that is my domain. Okay, so it starts, I'm going to go from left to right, because even I don't have to do set notation that way, but when I do it that way, it just flows really nicely into interval notation. So he starts right here. Do you agree? And then he goes all the way up until he gets to this point right here. So it is all the x's between here. Okay? So I'm going to say any x such that if the x's are between, I'm going to put the x between. I always point my arrows to the left, and that way, logically, the little number goes on the left and the big number goes on the right. Okay? So this is where it starts at -2. Is it included or excluded?
Included.
Very good. It's a solid dot, and that means a line. That means included. That means a bracket in interval notation, and that is -2. Are you with me? Okay, so x is greater than or equal to -2 and less than, and it has a hollow dot. What is that? Not included. So don't put a line under him, and he goes all the way to 4. Now, I like writing it this way, and the reason is, he's all set up for my interval notations. My smallest number is on the left, so -2. He is included. He's a solid dot, so he's a bracket. Remember how we talked about a bracket? Looks like someone standing there with their arms open, and they're like, come on, I'll include you. Okay, whereas a parentheses just standing there, bending away from that person, trying not to touch them.
They're
like,
in the middle of doing the
yeah,
YMCA.
4th grade boys and girls and cooties. All right, so this guy right here, all the way to 4, and he is not included. Okay, all right. So everybody Okay, so let's do the range. Well, I'm gonna do the same thing. I'm gonna box that in with respect to my y-axis. I am starting from the bottom because that's the smallest. So it goes from here, and it goes all the way up to this guy right here. They are both solid, so they're both included. So my range is going to be any y such that y is between. So I'll point my arrows to the left. They're both included. The smallest number, negative 1, 2, 3, 4. So y is greater than or equal to negative 4 and less than or equal to positive 1, 2, 3, 4, 5. In interval notation, I'm including both of those endpoints. So from negative 4, comma, to positive 5, both inclusive. Anybody got a question?
Wait, on the range, that's a -1, right?
I don't think so. Negative 1's usually are just like this.
I just couldn't see it.
Negative 4. Does that help?
Yeah.
Is that good? Alright. Okay, so here we go. Y'all ready to do B? Okay, y'all did that one by yourself, so I'm pretty sure you can do this one by yourself. This one's gonna be just a little more difficult. Alright, domain and range, both ways, proper set and interval, just so we practice and stay good at it.
So do you want us to do the things off to the side as well?
Things off to the side. What's off to the side?
Oh, no, never mind. I was kidding.
That negative 1.
Haha, joke, gotcha.
Okay, so I'm gonna do my domain. I started on the right-hand side because I was a little more sure about the right-hand side. I'm like, I know it stops right here, and I know it goes back. What does this arrow say that he keeps doing?
Going.
Yeah, he keeps going. So he's gonna keep on going all the way that way. So my domain is any x such that, what?
X is element.
Less than 2.
You don't have to say it's an element of if you're doing inequality.
X is
Less than 2. Very good. Included? No. Hollow dot. Okay, not included. You're correct.
So what if I did the other one first?
It's fine.
It's okay. So the other one is going to be, what is this left arrow going to? And do you include infinities? Never include infinities. So it's parentheses, negative infinity, all the way up to 2. That is also not included. Okay, so now I'm going to do the range. Let's see. The range is kind of weird, isn't it? Is it all together? No, it's separated. So it's either this piece right here, or, that's a union symbol, it's this piece right here. Okay? So remember that on interval notation, you have to start with the smallest number. So on set, we're going to also, it looks nicer, any y such that this y, he's between -1 and -4. So I'm going to put him there. I'm going to point my arrows to the left. Y is greater than -4. Is he or equal to? No, it's an open circle, that's not included. Y is less than -1. Is he included?
Yes.
Yes. Or Y is what? Greater than 3. Not equal to, because it's an open circle. Okay? In interval notation, he's going to look like from -4, not included, all the way to -1, which is included, or he's from 3, not included, to positive infinity, never included. Anybody got a question? Nope, everybody good? Okay, I'm gonna do this next problem, even though we talked about this problem the other day. So if it were just this class, I would let this go. But since it's on the video and we did have people absent this morning, I'm gonna go ahead and put it on the video, okay? So example 2, find the domain, the range, the x-intercept, the y-intercept, the parent function. What am I mimicking?
The worksheet.
Yes, the parent function and the transformations.
Oh, so this is already on our worksheet.
Yeah,
We don't have to do
so this is just like on your worksheet where you are asked to find all of these things. The actual problem in the book doesn't say to do that. He just says find the domain and range. But I wanted to make sure that everybody knew how to do that, so, because on the worksheet it's gonna require you. So here's my function, f of x is equal to, the square root. You know what, I'm gonna put a 2 out here, okay? 2 times the square root of x minus 4, just because I wanna talk about something, okay? 2 times the square root of x minus 4. Alright, so I'm going to graph it first on the worksheets. They're asking you to graph it, okay? And I'm going to graph it first because frankly, from a graph, I can read really well a domain and a range, okay? I could use this, you've been taught this. If there's an x under the radical, there's a restriction. You take what's under the radical, you say you have to be greater than or equal to 0, you solve for x, and it says x is greater than or equal to 4, okay? But I'm gonna do a graph, because I like it. And you have to do a graph on that worksheet anyway. Oh, stop. Okay, so I remember I was very picky about that. And I said, I don't want any tick marks on there that you don't need. Okay, so I don't want any tick marks on there that you don't need. So here it is right here. What is this 2? Is he an X or a Y?
Y.
How do you know he's a Y?
Because he's not with an X.
Yeah, he's not inside there with an X. If he had been in there on that X, that 2, then that would have been different, okay? So he is a Y. So he is a vertical what?
Stretch.
Stretch. If it's bigger than 1, it's a vertical stretch of 2. Remember how I said I wanted the number? If it's between 0 and 1, it's a vertical compression of like 1/2. Okay? What does this minus 4 do to my graph?
Right.
What? Right
forward.
forward. Okay, so that's why I made 4 tick marks to the right. So I'm gonna go 1, 2, 3, 4. And here's where my graph starts. Now, it has a vertical stretch of 2. So how am I gonna make the next point? Y'all, if it didn't have a stretch or anything, you just go up 1 and over 1. Okay? So, but it has a stretch of 2, so tell me what to do.
Up to over.
Yeah, up 2 over 1. Now let's talk about what happened yesterday. Well, we'll talk about that in a minute. So anyway, so there's my graph. Has everybody got it? That's what it looks like. Let's talk about my domain. let's just do interval notation, because that's what we're doing on the worksheet, okay? Interval notation. Where does it start?
Forward,
4. All, is it included or excluded?
included,
All the way to,
positive infinity,
very good,
never included,
very good. Range,
Zero.
0, included or excluded? 2, positive infinity, because he keeps going up, ever so slightly, but he is going up. All right, anybody got a question? Okay, so just for the sake of the people that are watching the video, if anybody is, and you know, by all means, if it's helpful, okay, because we know some people, it's not helpful to them, right, Travis, Colton?
Hey, listen,
Huh?
it was a joke,
I know.
it was in this class, no, I did the call me.
Oh, thank you. Thank you, thank you. All right, so I'll get that little stick back out of the trash can. All right, so x-intercepts, how do you find x-intercepts? Yeah, make y equal to 0. How do you find a y-intercept?
X equals 0.
X equals 0. Okay, so if I'm going to look for an x-intercept, okay, an x-intercept, then all I'm gonna do is take this function and I'm gonna set it equal to 0, because y is 0. So it's gonna look like 0 is equal to 2 times the square root of x minus 4. Now what am I doing? Yeah, but how?
Divide by 2.
Yeah, divide by 2. What's 0 divided by 2?
0.
Okay, now, can you solve for an x when it's underneath the radical? Can you solve for an x when it's in the denominator of a fraction? No, y'all, those are things you can't do, okay? So I have to get it out from under this radical. Tell me what to do.
Square both
Yeah,
sides.
square both sides. I can square this side, that's the whole purpose of it. But the thing says what you do to one side, you have to do to the other. What's 0 squared? This squared takes care of that radical, and I'm left with x minus 4. Now what do?
Add 4.
Add 4 to both sides, and x equals 4. Okay, so my x-intercept is 4. And I said, people just write it. Don't try to be all fancy schmancy and go, it's 4, 0. Because at some point, you're going to flip that around and mess it up. All right? You don't want to risk it. Now, what if I want to find a y-intercept? What do? Oh, that's the easiest one. A y-intercept. All I do is put a 0 in for this x. So I say y is equal to 2 times the square root of what's x? 0 minus 4. So that is 2 times the square root of negative 4. Ooh, this is getting weird. What's the square root of negative 4? 2i. So this is 4i. Are there any imaginary numbers on this coordinate plane?
No.
No. So my y-intercept, there is none. Does that look like what's going on with my graph?
Yes.
Yeah.
Wait,
So I'm
how do
like,
we know
okay.
so there's a negative under the radical, so when you square it, it's 2, and then you multiply 2 times 2, and that's how you get 4,
Uh-huh.
and then you just put the I, because it's negative.
Okay? So, parent function, okay? Parent function.
Square root.
Square root. Okay, so this guy right here, he's the square. This is the pen that's out of me. Yes.
You should have said it by number.
Okay. So, square root function. What does the equation look like? Because I said you had to do both. F of x is equal to square root of x. Is that helping you on your test for tomorrow? It should be helping you, okay? It's bringing that stuff up in your head.
I know this one, and I know
Okay.
the rest.
Transformations, all right? I'm gonna write the rules down for transformations, and then we'll write those down. So we're gonna write, these are for anything, the transformation rules. Okay? The very first thing that you should address is if there is a negative on the y. Okay? And that would mean if there is a negative outside here, okay? outside, not with the X, but he's outside, so he's on the Y. If there's a negative on the Y, then that reflects it over the X-axis. Do not use the word flip. Reflects over the X-axis. Notice that he reflects over the opposite axis. If it's on the Y, it reflects it over the X-axis. Obviously, if it's gonna be on the X, it's gonna reflect it over the Y. That's the most difficult ones, okay? Then you would need to address any vertical stretch by, and you would say whatever the number is, okay? And that would be, if it was a number greater than 1, it's a vertical compression by whatever that number is. If your number, need a little more room. If my number's between 0 and 1, okay? My brain says to myself, hey, it's really less than 1, but it's not, we're not dealing with negatives. So it's less than 1, but it's greater than 0. Okay? The negative is dealt with up here. And then you would do horizontal and vertical transformations. I don't care about the order of them. Remember that if it's with an X, it is an X. It moves it left or right, opposite of what you think. If it's not with an X, it's a Y, and it moves it up or down, just like you think. Does everybody understand? Okay, and then the last thing, well, let's do one more. Let's put one more in there. If you have a horizontal stretch or compression, okay? Remember, they're gonna do the opposite, so it's going to be a stretch of, and what you're gonna do is you're gonna take the reciprocal. Okay, a stretch of the reciprocal, and that would be if your number is what? What's gonna make a horizontal stretch?
Less than 1.
Yeah, he's gonna be between 0 and 1. All right, it's gonna be a compression.
Say a stretch as if it's little.
Cause it's with, cause this is with an X.
Okay.
All right, he's gonna be with an X, so X's always do the opposite. A compression of, he would also be the reciprocal. All right, and that time your number would be greater than 1.
So if it was 2, it'd be a stretch.
1/2.
Because we take the reciprocal.
If your number inside, if there were a 2 inside here, it would be a compression of 1/2. Okay? If the number inside here was 1/4, it would be a stretch of 4. Okay? All right. And then the last thing that you will do is if you have a negative on the X, he will reflect over the Y-axis. Okay? He will reflect over the Y-axis. That right there is the most difficult skill. This right here, he's kind of catches some people, but most people, we've been saying stuff about X's and how they're weird, but they're always weird long enough that you get that. But this, reflecting it over the Y-axis, that is a lot more difficult, okay? Like, this guy right here, if you wanted to reflect him over the Y-axis, then he was going this way. He's looking like this, and then he reflects and he goes over here, and now he's at -4 and he's going this way.
If
You see
put
what I'm
a
saying?
negative in front of the X.
If I put a negative in front of the X, that's exactly what would have happened to it. Okay? All right, so let's do this guy's transformations. Okay, so is there a negative on the Y?
No.
No, so I don't need to do that. Do I have a vertical stretch or compression?
Yes.
What is it?
Correct.
So I have a vertical stretch, what? Very good. Stretch of 2, okay? Now, well, remember this, guys, that when you do stretches and compressions, if it's not a line, you can only do it one time, right? And how much can I move out, away? 1 unit. 1 unit to the right or the left. You can't move more than 1 unit, all right? I'm gonna show you, because I'm gonna show you, that's what happened yesterday with that 1/2 thing. So I'll show you that so we don't mess that up. Does he move, left or right?
Yes.
Where's he go? Right 4, okay? Does he have any horizontal stretches or compression?
No.
Does he have a negative on the X?
No.
So those are all my transformations. Okay? Now, let's talk for just 1 second and then we'll do the next step. So this is what happened yesterday. Your function, f of x, was equal to 1/2 x squared. What else was it? Minus 2. Okay? So when we started to graph that, you went where? Down 2. And there's my vertex. What is this? What's it gonna look like?
The parabola.
It's a parabola. What's it called? What's the parent function?
Quadratic.
Quadratic, okay? F of x is equal to x squared, all right? So he doesn't go left or right any, but he does go down 2. Now, is this guy right here a vertical or a horizontal something? Why is he vertical and not horizontal? What would he have to be to be? Yes, he would have to be in parentheses with that x to be what y'all were calling him, okay? If he's horizontal, he has to be in parentheses with the x and then both of them squared, okay? So this is a vertical compression, all right? So it has a vertical compression of what? 1/2, okay? So this is what happened. Kids went up 1 and then they went over 2 and made a dot. You can't do that. You can only move away from this vertex to the left or to the right 1 unit. And since this number is smaller than 1, you're gonna have to move up or down this many units and then just go over 1. So what you have to do is you have to go up 1/2 and over 1 and up 1/2 and over 1. And that's the way you use it to draw, okay? Because what happened was y'all went up 1 and over 2 and you ended up here and then it was an x-intercept. Well, it can't be here and an x-intercept, okay? So let's just try and remember that when you use this, remember how I keep saying you can't call it a slope, it's not really a slope, because this is a curve. Just remember you can only go out left or right 1 unit, no more than 1. All right, everybody okay? Okay, so we're gonna talk about increasing. What does increasing mean?
Bigger.
What? What'd y'all say?
Bigger.
Okay,
More.
how's the graph gonna be going? Up? Yeah, going up, increasing, decreasing, how's the graph gonna be going?
One. Oh, wait.
Or remaining constant. What's constant gonna be?
Fast.
C.
In the periods.
People, we're talking about a graph.
Wow.
Increasing, decreasing, or remaining constant? Increasing, going up, decreasing, going down, remaining constant, the same, horizontal. Okay, are you with me? Here's
Wait,
increasing,
what would be a what would be a vertical line? Would that be,
decreasing,
would that be decreasing or increasing
that's not a function.
or constant?
That's not a function,
Are you
we're
sure?
not talking about it. Remaining constant, horizontal line, okay? So, here we go. This is to try and teach y'all, or try to keep you from making, y'all, these problems are super, super easy. But people make crazy, stupid mistakes, all right? So I'm gonna write some stuff down to try and keep you from making those mistakes. Here's the first thing you need to write. Increasing, which is going up. Decreasing, which is what?
Going down.
Going down. Or constant.
Same.
Yeah, that's the same. Alright, is talking about the Y. Okay, so those words are talking about the Y. Everybody got it? So when you choose those words, those are going with the Y's.
So
Alright?
is that why you said it can't be vertical, because it's y equals, but that would be x equals?
Well, it's not a that's not a function. We're talking about functions. Okay? Remember, increasing and decreasing functions. Alright, so the interval is talking about the x's. And you will only use parentheses. Okay, you will only use parentheses. No brackets.
No, I'm not brackets.
Okay? No brackets, people. None whatsoever, okay? We would have to throw down and fight and see who won that. Alright, if my husband was here, he'd be getting brackets just to see everybody fight. Never, ever put Y values in the interval. Because who's the interval talking about? X's. Okay? That's the biggest problem kids have. This is so stinking easy. These should be big, giant Christmas presents, birthday presents, Valentine's presents. Happy Valentine's. Alright? So I'm going to draw you a picture. What? 1 minute. Man, time flies when you're having fun. Well, draw this picture for me, okay? We'll do this one.
Does that say example 4?
Yeah, I know, it's just one. Okay? Here's my picture. This is an open circle, guys, right here, just so you know. That's an open circle. Okay? So what is my line doing first?
Going down.
So what would that be called? Decreasing. On which interval?
Oh,
Negative
From -2 to
0.
0. And then what's he doing?
Constant. From
Constant.
0 to 2.
What's my interval?
0 to 2.
0 to 2. Then what's he doing?
Increase.
From 2 to 4.
Miss Davis, she must die.
Well, life is scared us all to death.
I went to go sneeze and I tried to hold it in, but I was on the